This video was designed to give you an overview of the storm hydrograph and some of the likely questions that you will experience with regards to storm hydrographs. First of all, a storm hydrograph shows the impact of a precipitation event on river discharge, and all storm hydrographs have the following labels which you would need to understand to be able to answer an examination question on this. The x-axis on a storm hydrograph will always have time as its label. This can vary in terms of hours, it could be days, or it could be months, just depending on the exam question that you get. The y-axis will normally have two different labels. In this case we can see river discharge, which is labelled here, and we also have rainfall, which is labelled here. Most, if not all, storm hydrographs will show the precipitation event. So you can see here from these number of bars of this bar graph that we have a storm event happening in this drainage basin. So for each time period here you can see the volume of precipitation, and again that's important. Over to the line graph aspect of this, which is really the hydrograph that we want to talk about. Basically this is showing the impact that this storm event or precipitation event has on river discharge in this drainage basin. The response to any precipitation event will be different for different drainage basins because those drainage basins all have different characteristics. Some of the general points that you need to know or labels that you need to understand about the drainage basin. First of all, we have this line which is labelled base flow. This is basically the general normal flow without any impact of precipitation on the river. So just the normal flow of river or the normal discharge in the river. This next section, anywhere above this line, is referred to as storm flow. So any flow in this area is in response to this precipitation event. This green line up to here is referred to as the rising limb, and after it's reached its peak, it's referred to as the falling limb. Okay, so this will rise in relation to the precipitation event, and then it will fall after the precipitation event has ended. This is referred to as peak rainfall, and this is referred to as peak discharge. Obviously peak rainfall is the maximum amount of rainfall. This is the maximum amount of discharge in the river. The difference between these two times is referred to as lag time. Lag time again will be different for different drainage basins. So that's the overview. Maybe if you haven't quite grasped all those terms, it might be useful to rewind the video and have another look at it. In terms of thinking about a hydrograph, here's a slightly different graph. We don't have a precipitation event on this. This is really just to illustrate how you need to get this clear in your head. There are two real extremes of hydrographs. This line refers to discharge, which is similar to the one that we've just had, and we call that a flashy hydrograph response. Okay, and that flashy response has a number of characteristics. So you can see here that it has a very steep rising limb, it has a very high peak discharge, and if we could see lag time, it would have a very short lag time. The other extreme is represented by the blue line, and it's referred to as a flat hydrograph. And once again, flat hydrographs have certain characteristics. They have a low peak discharge, they have a gentle rising limb, they have a gentle falling limb, and they have a very long lag time, which we can't see on this diagram. So that's what you need to think about with regards to preparing for the exam. There are the overview of the labels, and there are your two extremes, flashy and flat, and their characteristics. Here's a likely exam question. So again, we can see storm hydrograph here. Remember what I said to you, that we get time along the bottom. In this case, it's days of the month. Discharge up the side, but we don't in this case have any precipitation event included on the graph. Obviously the green one for Mercer Creek is our flashy response, very high peak discharge, steep rising limb, and a relatively short lag time. Our blue one for the other creek is our flatter response, not as flat as we saw in the last diagram, but once again, lower peak discharge, longer lag time, gentle rising and gentle falling limbs. So, likely question you can see down below, describe and explain the effects of this storm event on both streams. So describe, we'll have to take figures from the graph, you'll be looking to quote discharge figures and maybe time figures, and then you'll be trying to offer some sort of explanation for that for 4 marks.